Gerçekten fotoğraf çekip paylaşabilir miyim? Kalabalığımız. Öyle düşünmeyin. İnsanlardan müsaade istemeden fotoğraf paylaşmak çirkindir, illegaldir yani. Bir sorun olan aslında. Ama tabii çok rastlamadığımız için bunlar. Benim köyden 100.000 tane fotoğrafım var. Can I take a photo and share it on social media? Ha? Çekiyorum var demeyeceğim herhalde. We have a problem set 4, problem 5.
Tuhaf çıkmamış ya. En güzel tarafı almamış.
Deniz tahtanın ne kadar yukarı kaldırışını kaldırıyor? Burada.
Mükemmel.
Şu an durayım mı?
Biraz indirirseniz. Mükemmel.
Now, what does it mean to span something? You have two vectors. There's something called linear combination. You have scalars, right? Your scalars can be multiplied by your vectors. So, using these two vectors, a linear combination means, in general, means some scalar times the first vector. I will call these v1 and v2. Some scalar times v1 plus some other scalar times v2 means a linear combination of these two vectors. Okay? So, this set, when you put these signs, it means the subspace spanned by these two guys. The subspace spanned by something means that the smallest subspace containing v1 and v2. Okay? How do you define that? Whenever you contain v1 and v2, since you are closed under scalar multiplication and addition, you contain all linear combinations of these. Okay? And when you check the set, when you make them span something, this is C1, V1 plus C2, V2, for C1, C2 going around all real numbers. When you check this set, you see that this is a vector space. This is a subspace. So, if this is a subspace, and if it is contained in every other subspace that contains V1 and V2, it means this is the smallest one. Okay? So, the explicit definition of the span of two vectors is this one. So I want ABCD to be inside this, meaning I want the vector ABCD to be a linear combination of V1 and V2. What should I do? I check for some scalar C1, C2. Okay. For some C1, C2 in reals, we need C1, V1 plus C2, V2 to be equal to ABC. What is this? Let's understand this one. So, which means...
Biraz aşağı.
Yukarısına gerek yok. Şurayı da mı görmüyor?
Tamam.
Şu force'u görüyorsa
Okay.
yeter. This means you will multiply C1 by this vector, write it, add C2 times the other vector, write it, and then you will equate it to the vector ABC, which means equality of two vectors means they are component by component equal, right? Every component will be equal. So check the first component of this linear combination. What is it? 3C1 plus 0 times C2, and I want this to be A. Okay? Then minus 4C1 plus 6C2, I want this to be B. And it follows as the same. C1 plus C2 should be C. 0 times C1 plus minus 3c2 should be D. How do I understand which conditions A, B, C, D should satisfy? So this is a system of linear equations. I want this to have a solution, right? So this system should be consistent. And the only thing that is needed is for this system to be consistent, that's all. So I will make this system consistent. Let's see. The coefficients of C1 are 3 minus 4, 1, 0. 0, 6, 1, minus 3. And I have A, B, C, D here. So this is why we learn solving the systems of linear equations. Obviously not, by the way. The main aim is to solve systems of linear equations. That's why we learn matrices, etc. And then we use it when necessary. So what should I see? Ay çok küçükmüş bu. Alright, keep this one and make everything under and up this one 0. Right? So multiply by minus 3 and add to the first row. What am I doing? Minus 0, 3 plus row 1. So 0 minus 3. Ne yaptım? A minus 3C. And then multiply by 4 and add to the second row. I will not write the operations from now on. This is the last time I'm writing them. 4 times this plus this, 0, 10, and B plus 4C. I have 1, 1C, and 0 minus 3, minus 3D. As you see here, these 3 rows are dependent, right? I don't want to bother myself with rational numbers that are not integers. So this one is independent from all others. So this row does not put any constraint on my thing, right? Bu row bana hiçbir sorun yaşatmaz, değil mi? C ne olursa olsun bir sıkıntı yok çünkü burası diğerlerinden independent. So since this row is independent, I will check all the other rows. What I need is what? Minus 3 times C2 equals D. On the other hand, it equals A minus 3C, right? D, buraya yazmasam ne olacak? Şu mu? Evet. D'yi görüyor musun? Evet. D equals A minus 3C. This is for sure. And when I multiply this by 10 and this by minus 3, they should be equal, right? So 10 times A minus 3C should be equal to minus 3 times B plus 4. Huh? These are the conditions that A, B, C, D should satisfy. Oldu mu? So that the system is consistent. So I don't know, from now on it's just algebraic manipulations and saying that A should be like this. C can be anything it likes, for example, because you have 2 equations with 4 unknowns, right? A, B, C, D are your unknowns, and you have 2 equations now. So 2 of them will be free, 2 of them will be depending on those 2 free. So you will solve this. You know how to solve this. Okay. Steni yaptık desek baz olayına girelim. Baz olayına öyle bir girelim ki tek soruda her şeyi halledip geçelim. 13. soru. In the problem set 4, I will solve problem 13. Neler yaşadığım belli değil şu an.
Evet, şu boynundakini bir çıkarsan.
Of ha?
Boynundakini bir çıkarsan.
Boynundakini çıkaramam. O benim cowgirl şeyim. Ne diyordum? Alright, I have something and I want to make this inside a basis of the space of polynomials. Okay? So, what does it mean to be a basis? A basis is a subset that can span everything, and it should be linearly independent. Being linearly independent for example, 4 vectors means that you cannot find any of them using the other 3. Okay? If you have 4 vectors and one of them is a linear combination of the other 3, it means they are dependent, right? This one depends on the other 3. So, to be linearly independent, it means you cannot generate one of them by the others. And, what else? A basis will tell you something about the dimension of something, okay? We know that for vector spaces, the dimension is the number of, let's say the number of elements in a basis. This is a fixed number, if it is finite. If not, it is some cardinality and it is again fixed. Sonsuz boyutlu şeyler öğretmiyorlar değil mi size? Alright. There are infinite dimensional vector spaces, but apparently we are not talking about them. So, the space of polynomials, it has a standard basis, right? What is it? The standard ordered basis for the space of polynomials is these ones. When I write 3 here, it means all the polynomials by real coefficients of degree at most 3. Okay? This is the polynomials of degree at most 3 using real coefficients. You can make this happen by any vector space. Yakamdan ötürü olmuyormuş şeyden değil ki. Yakamı şunun içine mi sokayım? Böyle bir paçavra gibi. Okay. So I have something. I have some basis, which means I know the dimension, right? And I have 2 vectors and I see, gören gözler için, these are linearly independent, right? 2 vectors, when you're looking at 2 vectors, you don't have to write all the definition, etc. If one of them is a scalar multiple of the other one, they are linearly dependent. If not, they are not, right? So, dependence independence of 2 vectors is easy to see. As this is not a scalar multiple of this one, it is x times this, but there is no multiplication of vectors in our life, right? We do not multiply vectors. So, these are linearly independent. What should I do? I want a basis of all polynomials containing these 2. Bunu size nasıl gösterdiklerini bilmiyorum. Kolonlara mı yazıyorlar, row'lara mı yazıyorlar? Birisi derse gitmiş olsun.
Ben buraya gelirken bunu size soracaktım.
Ben de. Çok iyi. Bu jenerik bir soru, kesin çözüyorsunuz. Kolon yazıyorlar. Tamam, çok iyi. Okay, there are ways of looking at this. But the main thing is looking for the coordinates. Okay? This guy has a coordinate column matrix for this basis, right? This basis is my standard basis. And what coordinate means is this 1 plus x squared. Let's call our standard ordered basis as beta. Bunun sıralı olması önemli. Tamam mı? Sırasını değiştirirsem her şey değişir. This basis should be ordered and I should fix the order of it. So for the polynomials, we use the standard basis starting with the 0th power of x. And then you go until whatever you need. So let's call this basis beta. This is not beta. This is beta. Alright. The coordinates of 1 plus x squared in beta, what does this mean? Well, a basis means something that you can generate everything in a unique way. Since they are linearly independent and they span all the space, when you look for some vector, you know that it is a linear combination of these guys. Give me any polynomial of degree at most 3, it is a linear combination of these 4. And it is there's a unique way of combining these to get your polynomial, okay? For each one, the constant coefficient just depends on your vector and it is fixed, it never changes. Bir taraftan bakıp bunun 3 katıyla bunun 5 katını toplayan, öbür taraftan bakıp bunun 8 katından bunun 3 katını çıkaran aynı vektörü elde eden imkansız. Tamam mı? Herhangi bir vektör uzayında herhangi bir vektör, herhangi bir baz için bu imkansız. Biriciktir koordinat dediğiniz şey. Bazın baz olması bundan kaynaklanıyor. So the basis, think of the basis as an alphabet. Okay? This is the smallest thing that you can write your words with. Your words are your vectors. You can write any vector using these guys. So this is your alphabet. This is the simplest thing you need. Okay? So when you write 1 plus x squared using these guys, there is a unique expression. You have to take 1 of this, 0 of this, 1 of this, and 0 of this. Right? So write them down, and it is your coordinate matrix. What is it? 1, 0, 1, 0. Okay? And write the other one, x plus x cubed, it is now 0, 1, 0. When you look at them in this way, you see that they are linearly independent, right? Obviously linearly independent. So, doing this actually, it maps your vector space to R4, R to the power 4, okay? You have 4-dimensional vectors for every vector, so you can write an isomorphism. Isomorphism öyle mi oluyor? Shit. Okay. Well, but you know the idea, okay? Being isomorphic is just being the same, colored with different colors, okay? When you look at a polynomial, you can think of it with its coordinate matrix, nothing changes. When someone gives you a coordinate matrix, you can understand which polynomial they are talking about, right? Tamam mı? Koordinatlarla polinomlar birebir eşlenmiş. So adding things, adding polynomials will correspond to adding their coordinate matrices. Okay? This is just making something look nicer and dealable somehow. Handleable diye bir uydurduğum kelime var. Çok güzel. Alright. So what am I looking for? I want a basis that contains my guys. So I start with a spanning set. Set S. You have this 1 plus x squared, x plus x cubed, and you put 1 x squared, x cubed. Do this set span all the polynomials? Right? It does. Because even if you don't have these guys, it still spans. So S spans all the space of these polynomials. Then what? I want to have something that is linearly independent using this one. Well, I think this is too obvious because 1 and x will satisfy, but I will show you the method of it. So, create a matrix using the coordinates of all these guys, which means put 1, 0, 1, 0, this is the first one, 0, 1, 0, 1, and then the identity matrix actually. This one. I will reduce this matrix until it is in row reduced echelon form, and then some of these guys will die because they are linear combinations of the other ones. They will die, and I will cancel the dead ones, go with the live ones. Okay? These 4 vectors, 2 of them will die during the making echelon process, 2 of them will stay alive, and I will add that 2 into this set, and then I will have a basis. That's it, containing this one. So, what do? I can't do anything here. Yapayım mı hızlı buradan? Alright, this is a nice one, so I will keep the first row, this, and subtract it from the third one. Minus 1. What? 0, 1, 0. Ondan sonra keep the second one. Subtract it from the fourth one. Second one from the fourth one. We are left with this. What now? Ne oldu şimdi? Oldu mu istediğim şey? Şurada 1 mi var? Hayallerime eriştim mi? Erişmedim tabii ki. So now take the third row, add it to the first one, take the fourth row, add it to the second one, and then you will see what happens. I don't know what will happen now. Ne dedim şimdi? Take the third row, add it to the first row. Okay. 1, 0, 0, 0, 1, 0. Take the fourth row, add it to the second row. 0, 1, 0, 0, 0, 1, 1. Then 0, 0, minus 1, 0, 1, 0. Oof. Minus 1, 0, 1. From here, you see that all your leading ones, all your pivots are here, right? From this on, I don't need to go on. And I cannot go on, actually. My leading ones are here, here, here, and here. Alright, the first column was corresponding to my first vector, which you cannot see here, my first vector. The second column was for my second vector. The third and fourth columns were for 1 and x. So, let's say alpha, 1 plus x squared, x plus x cubed, 1 and x. This is a basis. Well, for me, understanding this was too easy because when I subtract 1 from this, I get x squared. When I subtract x from the second one, I get x cubed, right? And the only things I need were 1x, x squared, and x cubed. If I can generate them, I can generate the whole space. So if you have 4 vectors in a 4-dimensional vector space that span your space, it is a basis. If you have 4 vectors in a 4-dimensional vector space and your 4 vectors are linearly independent, it is a basis. Tamam mı? Bunların özeti var akşam koyacağım videoda. Ama hızlıca mesele şu. Hem span etmek hem linearly independent olmak baz demek. Hem linearly independent olup hem içinde dimension kadar elemanın olursa yine bassın. Hem span edip hem dimension kadar eleman olursa yine bassın. Bunlar birbirini getiren şeyler. Okay.
Durdurdum.
Oh.
Durdurdum.